Everyone, welcome to Sorting Algorithms, and today I'll be talking about bubble sort as part of my third year project. Yes, so bubble sort is a comparison-based algorithm. It repeatedly passes through an unsorted list comparing pairs of neighbours' elements and sorts them if they're not in the right order. Until no swaps occur, and then the algorithm will finish. But I'll slowly walk through each individual steps to show how the algorithm works. So for starters, I like to talk about the performance of bubble sort. So it is an array data structure. And the worst case time complexity of bubble sort is O(n squared, big O, because this is because of the nested for loops. And then for the average case, it is n squared as well. And then that's theta, big theta, n squared. And then for the best case, it is omega n. And then the worst case space complexity is big O1. So next then we'll talk about the algorithm. So here, this is the list of numbers, and then what the algorithm will do. This is the unsorted list of numbers. So what the algorithm will do is, it'll take this list of numbers and then compare the neighbor elements of this array, and then swaps them if they're in the wrong order. So the first pass will compare 4 and 1, and then since 4 is bigger than 1, they swap, so 1 and 4. And then the second comparison will compare 4 and 3, and since 4 is bigger than 3, then in that case 3 and 4 should swap too. And then it'll compare 4 and 2. So, and since 4 is also bigger than 2, it will also swap. So, and then it'll approach the point where 5 is bigger than 4, or should I say 4 is not bigger than 5, so it does not swap. And then 5 is confirmed to be the biggest element of the list, and then and then everything is relatively the same for the second pass. So it will be 1 and 3, and since they are the same, there will be no swaps. And then 2 compared with 3, 3 is bigger than 2, so there will be a swap. 3 is smaller than 4, so no swap, and then 4 is smaller than 5, so no swap. And then third pass, because there was swaps detected in the second pass between 2 and 3, then the algorithm will continue, because the algorithm does not actually know does not know the list is sorted. So the algorithm will continue, and then it'll compare 1 and 2, 1 is smaller than 2, 2 is smaller than 3, 3 is smaller than 4, 4 is smaller than 5, so all of them no swaps, and because there's no swaps detected, the algorithm will stop and detect that this list is sorted because the order is met, the condition is met, basically. And then what I'll be talking about now is the pseudocode for this algorithm. So actually, before I talk about that, I'll talk about the formula for the maximum number of comparisons to to calculate the maximum number of comparison and swaps. So the formula is n minus 1, and that's all over 2. That's to calculate the maximum number of comparisons and swaps. And now I'll talk about the pseudocode of bubble sort. So it'll take a list of numbers, and then this list of numbers will be assorted. That's what I talked about before. And then there'll be a do-while loop that will continue going around until swap is false. So that's when the algorithm detects that there's no swaps remain, and then it will tell the algorithm that the loop will tell the algorithm that the list is sorted. So at first you always initialize. So essentially, each going around the while loop is essentially a pass for the algorithm. So in the first pass, you always set swap to false. This is just to keep track of whether there has been a swap or not in that pass. So then this will index through the array, and then when it indexes through the array, it will compare the current element of that unsorted list to the element that succeeds, so to the next element. And then if the current element is bigger than the next element, then you swap the two elements that's in question. And then once you swap, you change it to true, so then the algorithm will know that there has been a swap, the algorithm has not been finished, restart, and keep going, so keep going around the loop. And this is the nested loop, so a do-while loop and then a for loop inside it. This is why the complexities, the efficiency isn't so good for this algorithm. So once there's no swaps, swap will remain false, and then it will leave this do-while loop, and then the function will end, and then your list will be sorted. So then next I'll be talking about the advantages and disadvantages of bubble sort. Like I said before, bubble sort, like I just described now, bubble sort is a simple algorithm. It is simple and very easy to learn. And very easy to learn and understand. But it is a very slow algorithm to run and very impractical. So impractical compared to much superior algorithms, for example, like merge sort, quick sort, and heap sort. The best case of this algorithm, so essentially when to use this algorithm is when it is applied to a near good, so it's basically good for arrays in nearly sorted arrays. So basically here's an example. So if it's 1, 2, 3, 4, 6 and 5, the first pass you will be going through comparing no swaps, and no swaps, and then there'll be one swap here between 6 and 5, and then in the second pass it will be 1, 2, so once you swap, it'll be 1, 2, 3, 4, 5, and 6. So then in the second pass, it'll run through this algorithm, detect no swaps, and then the algorithm finish. So it's much quicker than it'll be much quicker than the worst case scenario, where your numbers are, your input list is actually 5, 4, 3, 2, 1. In that case, there'll be the first pass will run through literally all. We'll run through that will swap, that will swap, that will swap, that will swap. So the second pass will be 4, 5. Actually, no, it won't. It will be 4, 3, 2, 1, and then 5. And then the third pass will be 3, 2, 1, 4, and 5. And then you can see the list is still got a lot more passes remaining, so it's a lot longer. So the difference between a nearly sorted array and an array in the complete opposite order will yield much different results when running the algorithm. So next then that's a disadvantage because the worst case is much slower. And then lastly, bubble sort can be optimized further. So as you can see through the first pass, you realize that 5 is the largest element of the list. So in the second pass, what you essentially could is in the second and also the passes after the first pass, you can essentially reduce your size in a way of you can reduce the amount of numbers you can compare to. So basically, you only need to compare 1 and 3, 3 and 2, and then there'll be swap, and then there'll be 3 and 4, and then there'll be a swap, and then you don't even need to consider 4 and 5 because you know 5 is the largest number. And then for a input size that's much different, you can then realize that 4 is the next biggest number after 5, so then you can ignore 4 in the third pass, and then so on. So then your number of possible comparisons decreases by 1 each time, which is why the formula to calculating the maximum number of comparisons is n minus 1 over 2, because you're decreasing the number of the numbers to compare by 1.